Oh, is it time? Catching up on my reading. Today we're going to talk about the greenhouse effect. We're going to take some notes on the greenhouse effect. We've already talked about it a little bit in class, and certainly you've done the lab on it that you should have finished up in class today. Alright, so the sun gives off radiation in the form of visible light. That's why your eyes see visible light, because they evolved to see what the sun gives off the most of. For our purposes, we're going to call it shortwave radiation. I've got a graph down here on the bottom of the screen that's showing the amount of radiation given off by the sun in the different wavelengths, and you can see that it's giving off predominantly visible, and then as you go into the UV and the infrared, it tapers off pretty quickly. The sun does give off some wavelengths of all forms of radiation, but obviously concentrated most in the visible light spectrum. So it's the greenhouse effect. So obviously it must be something like a greenhouse, right? So let's talk about how a greenhouse works. Greenhouses would be buildings that are made of almost entirely glass or some sort of transparent plastic that allows visible light to pass through it. The visible light is absorbed by the plants, the pots, the tables, the ground, whatever, and then it's re-radiated as infrared radiation. Now we're going to call infrared radiation long-wave radiation. The glass prevents, or the plastic, prevents the long-wave infrared radiation from leaving. So although it's transparent to visible light, it is not transparent to infrared. So the infrared gets trapped inside and warms it up and makes it warmer. Our school has a greenhouse out back. If you were to go out there, maybe not on a cloudy day, but on a sunny day this time of year, if you go into that greenhouse, which is really just a sheet of plastic thrown over some metal ribs, it's not insulated, there's holes in it, it's still probably 75 degrees on a sunny day this time of year. It is important to get the absorption and re-radiation part down in your mind. It's not being reflected, it's being absorbed and re-radiated. On this diagram, we're looking at some numbers from incoming solar radiation and outgoing solar radiation, and basically what it's showing is that some radiation is reflected by the atmosphere, some radiation is reflected by the clouds, some radiation is reflected by the ground. A good chunk, about half, is absorbed by the surface of the Earth and re-radiated. Of that radiation that gets re-radiated is infrared. Some goes out into space and some gets absorbed and re-radiated again back down to Earth to warm it. So we talked about a greenhouse and how it works. Let's talk about how the greenhouse effect works. The atmosphere, like the glass, is transparent to visible light. Visible light travels through it, and the ground is not. So it absorbs the visible light and then re-radiates it as infrared. We saw this when we did the black can, silver can lab. The light bulb was giving off visible light. The cans were absorbing it and turning it infrared, and some of that infrared was being re-radiated outward, some inward to warm up the can. The long-wave infrared radiation gets absorbed by greenhouse gases. Some of the greenhouse gases that are common in our atmosphere are carbon dioxide, methane, water vapor, and nitrous oxide. Now, carbon dioxide is naturally occurring because of plants in pretty small quantities. However, it's also given off as a waste product in the burning of fossil fuels. When I say fossil fuels, I'm talking about coal, gasoline, oil, natural gas, propane, methane, you name it. Methane itself is a very powerful greenhouse gas. It's given off basically by cow farts. Water vapor is a naturally occurring greenhouse gas, but also a waste product of burning fossil fuels. And nitrous oxide is predominantly a waste product of the burning of fossil fuels, especially coal. I've read somewhere that if you were to give up one meal of meat and exchange it for fish, poultry, or vegetables a week, you'd actually be doing more for the environment than if you bought an energy efficient car or a hybrid car, an all-electric car. Okay, so we've got the greenhouse gases being absorbed by the ground, re-radiated as infrared. That infrared radiation is absorbed by some of those gases we just listed in the atmosphere, and again, some of that is re-radiated out into space, and it's not captured, and some of that is radiated downward back toward the Earth, where it heats the surface of the Earth even more. The thicker the atmosphere, or the more greenhouse gases you have in an atmosphere, the warmer the planet is going to be. Let's take a look at Mars. Mars has very little atmosphere. The surface pressure on Mars is about 6 millibars. To give you an idea, we'll talk about Earth a little bit later, but the average surface air pressure on Earth is 1,013 millibars. So, you know, a lot higher. The mean surface temperature of Mars is minus 62 Celsius. Brr, that's cold. Too cold for life to exist. Now, right now we've got Martian probes examining the soil on Mars. They've found traces of methane, and it's possible that there was simple life on Mars at one point in the past. That point in the past when there could have potentially been life on Mars would have been when it had a thicker atmosphere and active volcanoes to provide a warm enough surface for liquid water to exist more often. Even today, there's the potential that liquid water occasionally exists on Mars, but not very often. Alright, so let's go the other end of the spectrum. We'll look at Venus. The surface air pressure on Venus is 92,000 millibars. Once again, Earth is 1,013 millibars, so Mars is about 92,000 times denser at the surface. The mean surface temperature on Mars is 462 degrees. Too much atmosphere, too much greenhouse effect. Makes it too hot. So we go to Earth. Earth, we've got a surface air pressure of about 1,013 millibars. It gives us a mean surface temperature of about 15 degrees Celsius. That is what we like to call just right. It gives us liquid oceans, a thicker atmosphere but not too thick, just right for life to exist. I'm done. Again, if you have any questions, please write them down in your paper and we'll talk about them in class next time. Thank you.